Hi students, in the last class we have discussed problems based on Nernst equation, and in today's class, that is lecture number 6, also will start with some more problems based on Nernst equation only. Right, see here, find the electrode potential at 25 degrees centigrade for H2SO4 whose concentration is 0.05 molar oblique H2 and its pressure is 1 atmosphere. Means which electrode has given? It is absolutely hydrogen electrode only has given. It is hydrogen electrode only. Why? Because H2SO4 contain H plus ions. H2SO4 contain H plus ions. Meaning is H plus oblique H2. H plus oblique H2. Nothing but it is hydrogen electrode only. Right. Now given symbol we'll write once again. H2SO4 oblique H2. First H2SO4 will split like this. It is giving a 2H plus SO4 minus 2. Why we are splitting H2SO4? Because H2SO4 is diprotic acid. It contains, we can say that dibasic acid. It is having 2 protons in it. Here H2SO4 concentration has given 0.05 molar. But H2SO4 contained 2 H plus ions. Because of that, what we have to do? H plus concentration purpose, we have to multiply 2, given concentration with 2. 2 into 0.05, nothing but 0.1 molar. Means here H plus concentration means we have to take 0.1 molarity only. Don't use 0.05 molar, because this is entire sulfuric acid concentration. We need H plus concentration only. It is a dibasic acid. It is having a 2 H plus ions. That's why 2 into 0.05, that is a 0.1 molar. 0.1 molarity. Okay. Now we will observe the symbol. H2SO4 contain H plus oblique H2. H plus oblique H2 is nothing but again reduction symbol only. We will write its relevant reaction like this. H2SO4 is having a 2H plus. Okay, because it is splits like 2H plus and SO4 minus 2. And of course I am not considering SO4 minus 2 ions. I will consider only H plus oblique H2. That's why H plus, by taking 2 electrons converted as H2. It is again a reduction symbol only. That's why we have taken its related reduction reaction like this. And to this equation again we will apply Nernst equation. See here, H plus oblique H2, or we can write 2H plus oblique H2 is equals to E naught 2H plus oblique H2 minus 0.059 by n log base 10. Formula already known to you, that is a product by a reactant or reduced state by oxidized state. Here product is a gas. That's why we write it's a partial pressure of hydrogen divided by H plus concentration, H plus, but here stoichiometric coefficient is there. That's why whatever the stoichiometric coefficient is there, we'll write as its power. That's why H plus square, that is equals to here E naught H plus oblique H2, nothing but it is SHE, its value 0 minus 0.059 divided by n value. How many electrons are involving in this process? 2 electrons. That's why divided by 2 log base 10. Pressure of hydrogen, that is a partial pressure of hydrogen, already given in the question, that is 1 atmosphere. That's why 1 divided by H plus concentration. H plus concentration purpose, don't use 0.05. We have to take 0.1 only. Okay, that's why 0.1 whole square, that is equals to, of course, minus, if you divide this value you get a minus 0.0295 log base 10. Then 1 by 0.1, nothing but 10 to the power of minus 1. 10 to the power of minus 1 whole square, 10 to the power of minus 2. That is equal to minus 0.0295 log base 10. 10 to the power of minus 2, if you bring into the numerator, it becomes a 10 square. Okay, then that is equal to minus 0.0295 into, here we will have another formula, log m to the power of n. Log m to the power of n, nothing but n log m. Here n value is 2. Log base 10, 10 n log m. N log m, that's all. Then here log 10 base 10 value is of course 1. And if you multiply these two values, you will get a 0.0, you will get this value 0.059 volts is your answer. That is a single electrode potential, nothing but electrode potential of hydrogen 2 H plus oblique H2. And of course it is not a standard electrode potential, it is just electrode potential only. Of course that is also reduction potential only. Where we have calculated this value? We have calculated at 0.1 molar concentration and 1 atmosphere pressure. Suppose 1 molar concentration, 1 atmosphere pressure if you use, that is called standard electrode potential, nothing but standard reduction potential. But here pressure is 1 atmosphere, no doubt, but the concentration is 0.1 molarity only. That's why at these two conditions, this much electrode potential will be generated. That's all. The important point is H2SO4 is a dibasic acid. It contains 2 protons. That's why whatever the concentration of H2SO4 has given, that concentration you have to multiply with 2. Whatever the concentration you will get, that concentration only we have to use as H plus concentration. That's all. Okay. Next question. Right, next question is like this. For platinum H2 gas oblique H2O, reduction potential at 298 kelvins and 1 atmosphere pressure is question mark. That's it. Once again, here for platinum H2 oblique H2O, H2 oblique H2O is nothing but again hydrogen electrode only, and is asking particularly reduction potential is asking. Reduction potential of hydrogen electrode at 298 kelvins and at 1 atmosphere pressure. Right. First I will try to understand the symbol. See here, I will write here once again platinum H2 oblique H2O. H2O contains, already known to you, H plus and OH minus ions. H plus and OH minus ions. We are constructing hydrogen electrode. That's why H2 should contact with H plus ions. Here OH minus ions are not needed. We can cancel. In the previous case, SO4 minus 2 ions we can neglect. Here also OH minus ions we can remove them. Here H2 has contacted with H plus ions. Right. Again here, if you observe the symbol, H2 converted to H plus. H2 converted to H plus means whether it is oxidation symbol or reduction symbol, we have to tell them. Here we'll write its relevant equation. H2 converted to H plus. H2 by losing electron converted as H plus. H2 by losing electron converted as H plus means it is absolutely oxidation symbol. This is oxidation reaction, of course. Balancing purpose 2 and 2. In the question particularly, symbol has given oxidation potential and question is asking the reduction potential. I'll repeat, symbol has given oxidation related symbol and the question is asking reduction potential. Be careful. That's why what I am doing now, whatever the symbol has given, this symbol will do reverse. If a symbol is doing reverse, automatically a reaction also will become a reverse. Therefore, now our required reaction is we are doing reverse. That is a 2H plus 2 electrons gives H2. That's all. We are taking a reduction reaction only. Why? Because we have to calculate a reduction potential. Reduction potential purpose, we have to take reduction reaction only. That's why I have taken a reduction reaction. Right, again to this reaction we will apply Nernst equation. See here, E, H plus converted to H2. Of course, 2H plus oblique H2 is equals to E naught 2H plus oblique H2 minus 0.059 by N log base 10. Product concentration by reactant concentration. Product by reactant or reduced state by oxidized state. A reduced state is nothing but again hydrogen gas. Gas, nothing but we have to take its partial pressure divided by concentration of H plus. Right, here the stoichiometric coefficient is there, that is 2. Whatever the coefficient is there, we'll write as its power. H plus square. Right. Now E naught H plus oblique H2. It is of course SHE, whose value already known to you, 0 minus and 0.059 by N. How many electrons are involved in here? 2 electrons. Therefore 0.059 divided by 2 log base 10. Pressure, partial pressure of hydrogen already given in the question itself, that is a 1 atmosphere has given divided by H plus square. In the question, H plus information not at all given. Then without H plus we cannot calculate electrode potential of hydrogen. But if you observe the question, there is no H plus conservation. Then in this case, how to get H plus value is question mark. Again, we have to go back to our first equilibrium topic. That is, in water at a 298 kelvins temperature, in water at a 298 kelvins temperature, will have H plus concentration as well as OH minus concentrations. Both are same. That is, H plus is equals to OH minus is equals to 10 to the power of minus 7 m. It is a fixed value because H plus into OH minus value is 10 to the power of minus 14. That is ionic product of water. Okay, from that H plus or OH minus concentrations are equal and its value is 10 to the power of minus 7 molarity. Here of course we don't want any OH minus ion concentration, we need H plus concentration only. That's why whatever the concentration is there, that value I am using here. Therefore 1 divided by 10 to the power of minus 7 whole square, because H plus square minus, if you divide it at 0.0295 log base 10, of course 1 by 10 to the power of minus 7 whole square, nothing but 10 to the power of minus 14 minus 0.0295 log base 10. 10 to the power of minus 14, if you shift into the numerator, it becomes a 10 to the power of 14. That is equal to minus 0.0295 log m to the power of n. Log m to the power of n formula is n log m, and here log 10 base 10 value is already known to it is 1. Therefore 14 into this value, if you multiply these two values, you will get answer in negative sign, and its value is minus 0.413 volts is its answer. That's it. Okay, here the important point is H plus concentration has not given the question. We have collected from ionic product of water concept. H plus value is 10 to the power of minus 7 molarity at 298 kelvins temperature. And here symbol has given oxidation, but question has asked reduction potential. That's why reduction potential purpose we have to take a reduction reaction only. That is very important. And in this reduction reaction is of course product, reactant, remaining procedure is same. That's all. Right. Next we'll discuss one more very important concept, that is another important concept is the calculation of EMF or cell potential of given cell. This is our next concept. Try to understand calculation of cell potential, electromotive force, EMF or cell potential of given cell. Given cell is one of the galvanic cell. And how to calculate a total cell potential we have to discuss now. Of course, here also we'll use Nernst equation only. That's why we can add one word, given cell, with Nernst equation. With Nernst equation. Right. Then, before we're going to discuss this phenomena, once again we'll just recall in previous case where Nernst equation we have used means say it is one single electrode and it is a zinc sulfate solution and its concentration is not 1 molar, its concentration is other than 1 molar, that is say 0.1 molar something, and a zinc rod has dipped. Then in this case how much potential has developed, that value has measured with the help of Nernst equation in the previous case. Like that, so many examples we can take. Again, suppose it is 0.2 molar copper sulfate solution and here copper rod has dipped. Here how much potential has developed, that also we have calculated with the help of Nernst equation only. Means individually we have calculated in the previous cases. Individually this electrode potential we have calculated and individually this electrode potential also we have calculated. Now what we have to do? We have to calculate total cell potential. Total cell means this electrode and this electrode if you connect like this. If both are connected, of course, salt bridge arrangement is also there. If both are connected like this, of course it becomes a Daniell cell. Why? Because one side is zinc, one side copper, absolutely Daniell cell. And now what you have to do? What is the total cell potential? We have to calculate. For that purpose, we have to derive another new formula that we'll see now. See here carefully. Now we'll do one thing. This formula also will derive first for Daniell cell purpose only. Okay. Now in the Daniell cell, left side we have taken a zinc electrode as well as the right side we have taken copper electrode. It is acting as anode, it is acting as cathode. Right. Now for Daniell cell only, we will derive the expression to calculate cell potential with the help of Nernst equation. Therefore, in the Daniell cell, at anode already known to you, zinc electrode is there. Now what I am doing, we'll write here once again. Now first what I will do, only for zinc electrode I will apply Nernst equation for single electrode potential. Only zinc electrode purpose I am applying here. At anode, E Zn plus 2 oblique Zn is equals to. Here which symbol I have taken? Reduction symbol only I have taken. Even though at anode oxidation is taking place, but we have used here reduction symbol only. E naught Zn plus 2 oblique Zn minus. Now I am using a Nernst basic formula, that is RT by NF. RT by NF, of course, when the Daniel cell we are using, how many moles of electrons are involving? 2 electrons. That's why directly we can write 2F ln reduced state by oxidized state. Then what is reduced state? What is oxidized state? For that purpose, we'll write a reduction reaction of zinc Zn plus 2 electrons gives Zn. Once again, I'll repeat. Even though zinc undergoing oxidation, I have taken here reduction reaction only. Okay, because we are using reduction potential values we are using, and we will calculate reduction potentials only. Right. Ln product by reactant, that is a Zn by Zn plus 2. Zn concentration of course 1 divided by Zn plus 2. Okay. Now then at anode, I mean this is Nernst equation for single electrode. Exactly. Now same Nernst equation will apply to cathode also. Therefore at cathode, then what is cathode? Cathode is a copper. Now here also I will write equation Cu plus 2 electrons gives copper. Again I have written here reduction reaction. Here also reduction reaction, here also reduction reaction I have written. Of course in the Daniel cell, here oxidation is taking place, here reduction is taking place, but to measure electrode potential purpose, both the places reduction reactions only we are using. Right. E Cu plus 2 oblique Cu is equals to E naught Cu plus 2 oblique Cu minus RT by NF to F ln of course product by reactant. Product is nothing but that is a metal concentration is 1 divided by Cu plus 2, that's all. Say equation 2, it is equation 1. Means Nernst equation we have applied for this electrode individually as well as to this electrode individually. Now what is our target? Here both electrodes are not having individually, they are connected to each other. Both electrodes are connected to each other. If both electrodes are connected to each other, then we cannot say as single electrodes. Now it becomes a cell. It is not single electrode because both are connected to each other. Now it is a cell. Now our target is total cell potential we have to calculate. Total cell potential we have to calculate. Total cell potential purpose we have to use our regular formula only, that is E cell. Total cell E cell is equals to E cathode minus E anode. That's all, because both reduction potentials only we have taken, and its derivation etc. we have discussed in the previous videos. Please go through those videos. Okay, right. Therefore E cathode minus E anode. E cathode minus E anode. Then why we are not writing E naught cathode, E naught anode? Because now both concentrations are not other than 1 molar. I mean both concentrations are not 1 molar, they are other than 1 molar concentration. That's why E cathode minus E anode formula we have to use. Now E cathode is nothing but this one. I'll write here, we'll start here. E naught Cu plus 2 oblique Cu minus RT divided by 2F ln 1 by Cu plus 2. Right. Till now or up to here cathode, E cathode formula we have written. Same from here to here, same value have copied here. Minus E anode. Anode is nothing but again this value we have to copy them. E naught Zn plus 2 oblique Zn. Then here minus we are writing, that's why this minus becomes a plus. RT by 2F then ln 1 by Zn plus 2. 1 by Zn plus 2. Therefore, in the next step what we are doing, both E0 values will write at one place. E0 Cu plus 2 oblique Cu minus E0 Zn plus 2 oblique Zn. Next, remaining is minus RT by 2F. We'll write here minus RT by 2F. Then ln 1 by Cu plus 2 plus 2. Then here minus we are using. That's why, but here plus sign is there. That's why here what I am doing, minus I am writing. Why? Because minus into minus, minus into minus will get back again plus sign only. Therefore, will already RT by 2F already taken common. Therefore, ln 1 by Zn plus 2, that's it. Once again, E cathode minus E anode is our regular formula. Cathode is nothing but this value. Anode is nothing but this value. Both values just we have to substitute, that's it. That's why E cathode value is from here to here minus E anode value is from here to here. Now E0 copper and E0 zinc, both standard electrode potential values will write at one place. Next, minus RT by 2F I am taking common. Remaining is ln 1 by Cu plus 2. Next, here already minus sign is there, but here plus sign is there. To get that plus sign, here you have to write minus only, because minus into minus will get that plus. And remaining is ln 1 by Zn plus 2. Right. Now we will extend that. That is E cell. E cell is equals to, see here, E0 cathode minus E0 anode is nothing but E0 cell. E0 cell we can write, because E0 cell is nothing but E0 cathode or E0 right minus E0 left, or E0 cathode minus E0 anode. Then minus RT divided by 2F. Then ln, see here one more formula is there, ln m minus ln n. Ln m, nothing but log m minus log n. Its formula is log m by n. Therefore, ln m value is 1 by Cu plus 2. It is log m divided by n value m by n. This again 1 by Zn plus 2. It is nothing but E0 cell minus RT by 2F. RT by 2F ln. Then Zn plus 2 is coming into complete numerator part. That's why Zn plus 2 divided by Cu plus 2. Which one? E cell is equals to. E cell is equals to. This is the formula. Now, this is exclusively for a Daniel cell. This formula is exclusively for a Daniel cell. Now, what I am doing here, we'll write one common general formula. That formula should be applicable to all the galvanic cells. For that purpose, we'll just modify. But before that, in a Daniel cell, where Zn plus 2 is present and where Cu plus 2 is present, we'll just write its net cell reaction. We'll recall its net cell reaction. That is, Daniel cell net cell reaction is Zn plus Cu plus 2 gives Zn plus 2 plus Cu is the net cell reaction of a Daniel cell. If you observe here, Zn plus 2 is in the numerator. In the net cell reaction, where is Zn plus 2? At the product side. At product side only. And Cu plus 2. Here in the Daniel cell, where is Cu plus 2? At reactant side. That's why here also formula is absolutely product by reactant. Product by reactant only. There is no doubt. For single electrode potential also product by reactant we have taken. For cell potential also formula is product by reactant. Product means product concentration divided by reactant concentration. Now here one small change we will do, that is this ln will convert into log base 10. That conversion already known to you. That is ln nothing but a log base equal to 2.303 log base 10. If you substitute here, E cell is equals to E naught cell minus 2.303 RT by 2F log base 10 Zn plus 2 by Cu plus 2, or Zn plus 2 is nothing but a product concentration, will write product concentration divided by Cu plus 2 is nothing but a reactant concentration. And again 2.303 RT by F, these values are standard fixed values. That's why by substituting all the values, like R is 8.314, T is 298 and F is 96487, if you substitute, then you will get E cell is equals to E naught cell minus 0.059 divided by 2. I am keeping as it is. Why 2 we are not using here? Because 2 is nothing but number of electrons involved in the process. This 2 is not constant, remember. 2 is not fixed. That's why 2 will keep. Whatever the fixed values are there, those fixed values only you have to substitute. You will get this much value divided by 2 log base 10 product concentration divided by reactant concentration. Now the final generalized formula we write like this. Final formula: E cell is equals to E naught cell minus 0.059 divided by, as far as Daniel cell is concerned, n value is 2. Then for other cells n value may be different. That's why here I am taking n. It may be 2, 3, 4, doesn't matter. Next, log base 10 product concentration divided by reactant concentration. Product concentration divided by reactant concentration. This is final equation based on Nernst equation to calculate cell potential of given galvanic cell. This formula also derived exclusively by using Nernst equations of single electrode potentials only. Then if you use this formula, directly we will get cell potential formula. Otherwise what we have to do then, instead of this formula also we can solve cell potential by another method. Another method means same. Then it is one electrode, it is another electrode. Now of course both are connected. First what we have to do, with the help of Nernst single electrode potential, only this electrode potential we have to calculate. Only this electrode potential value if you calculate, let it as x volts. Then again with the help of Nernst equation, only this electrode potential we have to calculate, and let it as y volts. Individually one side we are getting x volts, one side we are getting y volts. But I want a total cell potential. Total cell potential is nothing but right minus left, nothing but y minus x is your answer. Like that also we can solve, but it takes more time. Why? Because only left side electrode purpose you have to apply Nernst equation and you have to calculate, and at the same time then right side electrode purpose also we have to apply Nernst equation and you have to calculate. Then right value minus left value if you do, you will get a final cell potential. It takes more time. That's instead of that individual process, here directly if you use this formula, you will get cell potential without any problem then. That is E cell, nothing but a cell potential is equals to E naught cell minus 0.059 by n log base 10 product concentration divided by reactant concentration. Then here one more very important point is, before we going to solve the cell potential, first of all, by seeing the question, we have to write net cell reaction like this. Because without knowing the net cell reaction, which is product, which is reactant is bit difficult to identify them. I'll repeat. Before we'll going to solve the problem, by seeing the question, we have to identify which is reactant, which is product. How we are knowing with the help of net cell reaction, that is nothing but overall cell reaction. With the help of overall cell reaction, then here these two are the reactants and these two are the products. That's why product concentration nothing but these two concentrations you have to substitute. Reactant concentration nothing but these two concentrations you have to substitute. Like that, by using overall cell reaction, we will identify which is a product, which is reactant. That is very important. Right. Then with the help of this formula, now we have to solve some questions. Some questions based on given data. We'll see them. Once again, we'll recall same Nernst equation for single electrode. Single electrode purpose, how we'll write them? E is equals to E naught minus 0.059 by n log base 10 product concentration divided by reactant concentration. Formula seems to be same. Formula seems to be same, but both are completely different to each other. Here we are using a cell, E cell we are using, but here it is not cell, it is just a single electrode only. We have used like a Zn plus 2 oblique Zn, Cu plus 2 oblique Cu, like that. It is a single potential only. Here E naught value, and E naught values are standard fixed values you have taken. It is also single potential only. Minus 0.059 by n log base 10 product by reactant. Both are entirely different to each other. Here we are using E cell, E naught cell. But here it is E for single electrode, E naught also for single electrode only. Right. Now we'll solve only one problem and we'll stop there. Right, question is like this. Calculate the EMF, electromotive force of a Daniel cell. Daniel cell, of course, double L also we can write. Daniel cell when the concentration of ZnSO4 and CuSO4 are 0.001 molar and 0.1 molar respectively, and standard EMF of the cell is 1.1 volts. Right. This is the question. Please try to understand the question. Here calculate EMF, nothing but cell potential of a Daniel cell when the concentration of ZnSO4 and copper sulfate. Zinc sulfate, copper sulfate, both concentrations are given. One is 0.001 and other one is 0.1. Here both concentrations are not 1. Remember, they are other than 1 molar concentration. Respectively, and standard EMF, standard cell potential of the cell is 1.1 volts. It is of course fixed. Now, first what we have to do? Daniel cell net cell reaction will write. That is, just now we have written answer. Zn plus Cu plus 2 gives Zn plus 2 plus Cu. Okay, Zn plus Cu is Zn plus Cu plus 2 gives Zn plus 2 plus Cu. Here Cu plus nothing but copper sulfate. Zn plus nothing but zinc sulfate, that's all. Right, and these two are the reactants and these two are the products. And here Cu plus 2 concentration, how much they have given in the question? ZnSO4 value is 0.01. That's why I will write here. ZnSO, I will write individually clearly. Zn plus 2 concentration is equals to 0.001 and Cu plus 2 concentration is equals to 0.1. Both the values are taken from the question only. Next, here N value is 2. N value is 2 because Zn converted to Zn plus 2, 2 electrons. Cu plus 2 converted to Cu, there also 2 electrons are involving. And E0 and EMF, standard EMF is nothing but E0 cell is 1.1 volts. Now we'll write a Nernst equation for cell potential, not for single electrode potential. Remember, cell potential means E cell is equals to E0 cell minus 0.059 by N log base 10 product concentration divided by reactant concentration. Product means Zn plus 2 concentration, Zn plus 2 concentration as well as copper metal concentration also. But metal concentrations will take as 1 unit, that's why no need to write here. Divide by Zn concentration as well as Cu plus 2 concentration. But Zn is a metal, its value is 1, so we will write Cu plus 2 concentration only. See, after taking or after writing the net cell reaction only, we can identify which is a product as well as which is a reactant. That is very important. That is equal to E0 cell value is 1.1 volts minus 0.059 divided by N value is 2 log base 10. Zn plus 2 concentration is 0.001. We can write 10 to the power of minus 3 divided by Cu plus 2 is 0.1. 0.1 is nothing but 10 to the power of minus 1. 1.1 minus, if you divide, you will get 0.0295 log base 10. 10 to the power of minus 1, if you shift in the numerator, it becomes plus 1. Minus 3 plus 1, 10 to the power of minus 2. 1.1 minus 0.0295 log 10 to the power of minus 2. Again it is a log m to the power of n. Therefore, n minus 2 log 10 base 10. N log m, and this value is 1, and here minus into minus, it becomes plus. Therefore 1.1 plus, if you multiply these two values, you will get this one 0.059, and your final answer is 1. E cell is equals to, if you add then 1.159 volts is your answer. That's all. Means when zinc and copper, when zinc as well as copper electrodes are connected to each other, when concentrations are 0.001 molar as well as 0.1 molar, then the total cell potential value is this much. Total cell potential value is this much. That's all. And based on this formula, still so many questions are there. In the next video, we'll try to solve some more questions. Okay, thank you. Bye.